We are here at gotomath.com working some calculus, looking at continuity and one-sided limits, and this is the section we're in here. Let's go down and take a look at this problem. We got a piecewise function. Not traditionally written like this, but that's the way I'm doing it. We have the limit as x approaches 8 of f of x, and this is what we want to find. So let's move over to the whiteboard and write this out. We've got, now this is traditionally how you'd probably see it. F of x with a big curly brace. We have x squared, and its domain is everything except 8, and then f of x equal to 6, and its domain is only 8. We have the limit as x approaches 8 of f of x. Now some of the other problems in this section, as you can see, you've seen a minus or a plus sign here, but this one says that, well, we're coming in, find the left, coming in from the left and coming in from the right, and if both of those are the same, then that's what this limit is going to be equal to. Now let's sketch out what this guy looks like. If I can draw a straight line, that could help. Let's put 8 here on the x-axis since it's the interesting place. Now we got a parabola here. F of x is equal to x squared, and it says when x is equal to, or not equal to 8, right? So this is what's not in the domain, so we're going to put a hole right here in the graph and then come up like that. And of course this graph is not going to be to scale. Now what's the y value where this actual hole is located? That's what this is going to tell us, and my guess is it's probably 64. What about this guy here, f of x equal to 6? So this is a constant, but it's only defined when x is equal to 8. And like I said, this graph is not to scale, because obviously 8 wouldn't be here and 64 here, but you get the idea. Alright, so here we are. Now we're asked to find this, and that means that we're really doing this first. We're going to come in from the left-hand side of f of x. So if I'm taking numbers and I'm plugging them into the function, doing this, let's say numerically, coming into the function, right, as you can see here, as I get closer and closer to 8, but I don't equal 8, that's what the limit's all about. You get closer and closer to the 8, coming in from the left-hand side, my y value is getting closer and closer to 64. Alright, and then we do the limit as x approaches 8, coming in from the right hand side. So we're over here, and as we get closer and closer to 8, coming in from the right hand side, as you can see, my y value is getting closer and closer to this missing point here, this undefined place, and so that's 64. Now since both of these numbers are equal, we could say that the limit as x approaches 8 of f of x is equal to 64. Now what about continuity? Well, this graph is continuous everywhere, I'm saying, but except when x is equal to 8. So it's not a continuous graph on the real number line. But we have to check 3 things. First thing we're going to check is, of course, at f of 8. Well, at f of 8, it's equal to 6. Right? At f of 8, that should be a 6 there. I can't believe I wrote an 8. Okay, that's supposed to be a 6. You might have caught that, but at f of 8 you get 6. Both those guys are not equal, therefore it's not continuous at x equals 8.